So we're going to talk about the Trygve programming language tonight. It's a language that I started putting together in about May of 2015. So it's a little more than a year old. And it builds on about 12 years of research that I've been doing together with a guy named Trygve Reinskog. How many of you know who Trygve Reinskog is? How many of you have ever used Model View Controller? So he's the inventor of Model View Controller, among some other things. He's also been very big on using role modeling. Since many, many years ago. He has a book called Modeling the World of Objects or something like that, which I think maybe sold 500 copies in his lifetime. Because everyone who was buying an object-oriented programming book didn't understand anything about object-oriented programming. So how many of you do object-oriented programming? Really? Have done, yeah. In what language? Java is the only language in which you cannot do object-oriented programming. Now you can do it in C++ with enough abuse. You can do it in Ruby if you're using modules, and you can kind of fake it in a lot of other languages. Java is the one language in which you simply can't do it. You simply can't. And there have been a lot of good Swedes who tried. I was kind of hoping that maybe Richard Uberg might show up here tonight. So he's the one person who tried for years and years and gave up. And he essentially added some annotations to Java to turn it into another language, which was called Chi for J. And that was kind of one of the first working implementations of DCI. But it wasn't Java. It was a preprocessor for Java that was based on Java annotations. So I'm guessing what most of you do is not object-oriented programming. And it's important. What you're doing is class-oriented programming. You're not programming objects. And I don't know, does anyone here use a UML tool? Doing a UML documentation? So is most of it class diagrams? Yeah. And it was two weeks ago, was at the Models Conference in Saint-Malo in France. And Brand Sellish was there. He was the chair of the UML 2.0 committee. And he says, yeah, 70% of the people do is class diagrams. No one does object diagrams. And, we still don't quite know why. But the point is, there was this thing called object-oriented programming that was envisioned by a guy named Alan Kay back in the very early 1970s. And very few people understood it for about 5 years, and then it got lost. Because the class heritage of Simula came into the Smalltalk programming language, and that took the newcomers to Smalltalk out of the picture, because they started using classes. And then C++ came, and it was all over. So what most of you are doing is class-oriented programming. That is, you're thinking of classes. You're thinking statically rather than in terms of the dynamics that go together with object-oriented programming. So what I'm going to talk about tonight is a language that supports thinking in a more object-oriented way and even being able to express networks of cooperating objects in a closed form in a static program, which is a big step towards object-oriented programming. In terms of the modeling stuff, I actually got a lot of insight on that when I at this Models Conference. So if we want to go that direction, we can go that direction. And I learned there's a big difference between modeling and models. Every program is a model. It is. And a program is not the implementation. The program generates the implementation, usually through something called a compiler. So it's a model of the implementation. And it's one of the best models of the implementation we have. Modeling language were created to express all the stuff that the programming language people left out of the programming languages. So I just put it back into the programming language so that we can talk about it when we program, instead of having to translate from our mind into a modeling language and then from a modeling language into a programming language. This is stupid. We're going to stop doing stupid things. So that's kind of an overview of the night. So maybe, as I said, maybe it'd be good to start looking at some some real code here. Whoops, that's not spell check. So this is the environment. You can download this from GitHub. And it's written in Java. Apologies for that, but I don't know if I can. If I can, it's not obvious how. But yeah, so it has classes. This is a class currency, which is very general, very long, quite boring. And here we have euro, which extends currency. And so you see this, the language in its syntax is a lot patterned after Java. And the reason I did that was because of a phenomenon called worse is better. How many of you have read the Worse is Better essay? Good News, Bad News, and How to Win Big by Richard Paul Gabriel. So, I mean, he says that the last programming language was C, and that was the end of programming. And it may be called Java, and it may be called C++, it may be called C#, but it's C. And why did C succeed? Because it's the ultimate computer virus. It runs on anything. It runs on any old hardware that you have around. It's ubiquitously portable, and it's something, he said, the Lisp people really had a lot to learn from C. But that's why C is so popular, and why it was the last programming language. Well, this version of C is called Java, and it's ubiquitous. And I didn't want to scare people away. We actually had a prototype that did DCI that was written in Squeak, in Smalltalk, and it just went nowhere because it was just too foreign to people. People were just scared to download Squeak and didn't know how to get into it, didn't know how to get started, whereas everyone feels that, you know, they know how to get started with something that has curly braces. It looks like Java. So the classes, I mean, these are very, very much like Java classes. We still have classes. Here's an account, another class. Then we have a checking account, which extends account, and savings account, which extends account, and investment account, which extends account. So all these accounts. And what's important about a class in trygve, a class is basically just data with accessors. And the accessors are written in the domain vocabulary. So, I mean, if you're writing an object-oriented program and you ever have the word get or set in one of your methods, you do not understand object-oriented programming. You do not understand domain vocabulary. You do not understand domain analysis. You do not understand your business. You're thinking like a nerd. So, it's not add to balance, it's deposit. I mean, that's, you know, what the business term is. Add to is based on something that presumes that all of programming has to do with numbers, which is ridiculous. So, but the operations on a class should be very primitive. And as we discussed earlier, there may be many of them. I mean, some domains are very big. So this whole thing about thin interfaces and fat interfaces is crap. There's nothing wrong with a class having many methods. Because the alternative is to have many classes with a few methods. And then I have a forest of trees, which is a two-level search, which means another level of abstraction removed from what I'm interested in. This is stupid. And I mean we have grep. These things are easy enough to find. You don't need high technology to be able to find these things. So there's a lot of myths that have come in software engineering over the years. Class gas company. Oh, here's something new. Here's a thing called a context. Context called transfer money context. So what this is a use case. And it's a use case for transferring money from one account to another. And, you know, if I ask you, I mean, how many of you have multiple accounts in your bank? How many of you ever transfer money between those accounts? So tell me a short story. You know, you walk up to your bank. What does it mean to transfer money between two accounts? Use general terminology. So don't refer to your account numbers or even the kind of account, but in general, what does it mean?
In general,
Yeah.
I take money from
Yeah, be a little more precise. Good start. Good start.
So, no, I don't know. Yeah.
Well, one place. What's a good names are important.
Yeah. So I take money from one account and transfer them to a different account.
Okay. But probably in the way you're viewing those accounts in your mind, they have some kind of archetype, or you're stereotyping them somehow as having some properties. So can you withdraw from your phone bill and put it in your savings account?
Okay, no. So I'm taking them from my, I don't know, savings account and put.
But more general. And what I'm poking for here is source account, something I can take money from, and destination account. And if you probe people about their mental models, they carry around what's called an operational model, which is a little use case that we carry around for transferring money between accounts, and we know how to do this. And along with that goes insert your card in the ATM and enter your PIN and all of this, and we learn those models too. But our basic mental model is in terms of source accounts and destination accounts. Do you have a source account in your bank? Really? What's source account? Is that an object? Is that a class? You see, we've been missing something in object orientation all these years. It's called a role. And no, it's not a Java interface. Because roles actually have methods that bind polymorphically to the objects that they're operating with. And so our mental model, our basic makeup, is in terms of names that we give to objects. And the name of an object, according to its use, is called a role. The name of an object, according to its structure, is called its class. And so if I say fireman, that's the name of an object according to some use case or some cultural expectation. And if I tell you he's a fireman, all these cultural expectations come into play. And now, rescue kitten from tree, there's a use case, an operational model that we're going to talk about in terms of roles that this fireman is, and the fireman will play the role of a fireman. Now, can this object play the role of a fireman? Probably. Can that object play the role of a fireman? Probably. And there's some contract between the role and the object that the role expects the object to be able to do something, to be able to fulfill that role. So you probably can't be a quadriplegic and be a fireman. Probably. But okay, what's a context? A context is a use case. What is a use case? A use case is a network of interactions between objects in terms of these names that we call roles. So here's a very simple role called the amount. That's one of the roles in this use case. And basically it's going to take one of these currency objects that we talked about above and just publish all of its methods as valid role methods. And that's what this syntax does. But it says I require whatever object plays this role to have these methods. And this, in fact, is compile time checked. So it's completely compile time safe. What are the other roles? There's a GUI. There's a GUI role in the context for displaying the success. There's a source account role. We tend to capitalize role names. That's the convention in the community. And it has a method called transfer to. This is a real method. So it's not just an abstract interface to some method. It's real code. This really runs. And there's references in here like this available balance. Where's available balance? In the object. What class is the object? I don't care. All I care is that whatever object is playing this role meets this contract according to duck typing. So the class of the object becomes irrelevant, and we start to think in terms of objects and interactions between objects instead of thinking of instances of classes. And now, if I just look at all these roles, the destination account, the source account, and the amount, I can read the use case right here. It's all in one entity called a context. I can read it. You can't do that in Java. Why? By design. By design, you can't do that in Java. Why? Because if I'm calling available balance or something on myself, it's a polymorphic function. It's a hypergalactic goto. And which class that's going to dispatch to, I have no idea. And Java methods are unconstrained in their ability to go call other methods. I mean, who knows what that method will do? And I'm unable to read it because I can't even find it. And that leads us to the real design goal of trygve, which is a very humble goal, but probably the most powerful goal we can aspire to in programming, is I want to be able to write code that's readable. See, I'm an old guy. I've been programming since about 1969. So I've been through Fortran, I've been through Assembler, I've been through Pascal. I mean, you can understand a Pascal program. You can understand exactly if you do a procedure call where it's going to go. And therefore, you can test it. But we didn't have to do a whole lot of testing. What instead we did was code reviews, code walkthroughs, code inspections, and had big red pens, and usually that was enough to get the quality down to a pretty good point. I worked for AT&T for 20 years. We made pretty complex, reliable systems. These things could be down for, well, regulatory requirements were 30 seconds a year for all reasons, and actual practice was 5 seconds a year. That includes software updates. These were large, complex distributed systems serving 100,000 telephone customers. They had to be able to recover from double-bit undetectable memory parity errors that were caused by alpha particles. I mean, this is a hard problem. And trust me, we didn't get there by testing. You got there with good design and being able to understand the code. Object-oriented programming came along. And what happened? Testing became a business. Test-driven development became a big thing. Everyone had to do unit testing. Was all about the green bar. Just this morning, I was reading a keynote that DHH, how many of you know DHH? And he gave his keynote, and he has some actual case studies in that keynote where he says, we had this thing where we unit tested the thing to death, but it was some kind of banking system where they were moving documents around, and attachments were getting lost, and it was not pretty. I mean, like he made it really clear from the story, there was hell to pay. And he said, we unit tested the thing thoroughly, but no one had asked what should the system do? How do these objects interact with each other? And the reason that testing has been so popular is that we can't read object-oriented code because you have messaging rather than a statically understandable procedure call. We want to bring us back and kind of, reinvent the readability of code. Now, there's still going to be polymorphism, and in fact, available balance still is a polymorphic function. But it's dumb. It's a data accessor. It's like a get or a set, except it's in terms of the vocabulary of the domain. But I mean, there shouldn't be any surprises when we ask for the available balance. It's primitive, it's understandable, and we trust at this abstraction boundary that things beyond that are primitive, and that's a matter of the community working together, the design community that's building this. Or if I'm building it myself, of just being honest with myself. So we have this new thing called a context. Here's another context for paying bills. What it does is it starts with a source account, and then it's given a list of payees, of bills I'm going to pay. And for each one, it creates a new transfer money context to transfer money between those two accounts, and just says, go. Lights, camera, action. Start. Can you wiggle into a place here? Or there's a few spots left. Otherwise, Pull up a comfy chair or something. Welcome. There was a hand.
Yes, I have a question. Are you saying that what would previously be a rather complex method on some classes now instead of context? Basically, taking all of the code in the complex method and you pull it out and you put it in the context that leaves some kind of
Yes.
the whole class structure thing.
Yeah. Now, I mean, this is where I can maybe, and how do you use this? It's very simple. Just say a new use case, which is declared to be of type transform any context, is a new transform any context, and then say do it. And it will figure out, what its source account and destination account are, and bind them, and just run. But yeah, I mean, I have some slides here that explain a little more what's going on. And with respect to what you just said, at first I didn't show these slides in Copenhagen. Then I found they actually were pretty valuable. So here's our programmer, and down here is our user. And the user is using some software system, and this is called a tool. This is what Trygve calls it. And in the ideal world, this guy is going to build his tool. Now, right here somewhere elsewhere in this building, there are some children learning how to program. And they're being taught how to program by software engineers. And God bless them. These people are giving their time, to teach these kids. And I don't want to take anything away from that effort and their intent and all of that. But frankly, so for the past 5 years, I've been doing a lot of reading in childhood developmental psychology, looking at Piaget, looking what Alan Kay was trying to do. Where did objects come from? Do you know? Alan Kay was trying to build a computer to teach kids, or to help kids learn by being able to access their environment, and to build it as an extension of their mind into the world around them, into their library, into other people's minds and computers. And it was called the Dynabook. When was this picture taken? 1972. That's an iPad, for crying out loud. This is 1972. Now, this thing is just cardboard. But he did write a paper that showed that all of the technology was available at that time to actually build one of these for, about what you could buy an electric oven for. And it wasn't that unreasonable. And, of course, now we have this. It's the iPad. His vision was really amazing. But he was trying to do this. And what he wanted this thing to be is an extension of this child's mind. So she's sitting out here on the grass under a tree, and using this thing of an extension of her mind into the library down the street, and into the minds of the other kids around her who have Dynabooks, and growing her operational models. Source account, destination account, amount. That's an operational model. And that's what Piaget says we have in our left brains that we carry around. And the AI community kind of took those and called them, frames and slots. That's the East Coast view of what object orientation is. And then the West Coast view more followed the school of Piaget psychology. So the stuff comes from childhood developmental psychology and mental models. And then the nerds got hold of it in the late 1970s, and added classes, and the language wars started, and then, oh my gosh, the methodology wars, and it was all over. And we completely lost this notion that it's about objects. Now, does anyone here program in JavaScript? That's object-oriented programming. You write objects, right? And so you're thinking in terms of what object is in that person's head. Let me write that down. The bad news is JavaScript is getting classes. So, but, Kay said that this isn't about treating this child as a skeleton, a pigeon, or a rat. It's an actor. We'd like to hook into his current modes of thought in order to influence him rather than trying to just replace his model with one of our own. And that's what we do as designers, is we do this thing called modeling and then analysis and then design, and we force our users to adhere to that model. No. We want people to be able, models exist already. We don't need no UML model. The model already exists. I'll come back to these slides later, maybe. Come on. I got to stop doing so much animation. It really sucks. Yeah. So, how many of you have used Model View Controller? Model View Controller. This is not a UML model. This is a mental model of a human being. That's what trygve is talking about. Is the Alan Kay idea of taking that mental model, that operational model, and putting it into the machine. And then the purpose of the tool is to connect the mind of this child with that model. It's like, for me to teach you this stuff, I'd love to go in directly and manipulate the neurons, but it would be really messy. So I use this interface, right? His eyes, his ears, and I work through an interface that allows me to access that model and bridge a technology gap. That's what Model View Controller is. So we have the model that represents the end user's mental model. We have the controller. What's the controller do? It creates and coordinates views. Has nothing to do with input. Everyone says the controller handles input. No. You don't understand Model View Controller. The input can as well be handled by the view. And the view is what, I can have several views, each of which presents some projection or some aspect of this model. So here I have a programmer, and the programmer's job is to be able to understand and replicate what's in the mind of this user and put it in software so we can help the user and to do what they do. So if the user is using the system, I want to be able to reason about that in my programming language and consider the action between the objects and get that in my code. That's what the operational model is that Piaget is talking about. So if I look inside of this, there are objects interacting with each other. These objects that programmers created. And they may interact with objects that were created by other programmers or things in the network or things in a platform. And the interaction, of course, as we all know, is kind of messy. But for a set of objects implementing some use case, they form a system operation or a use case. And even though the objects or the classes of the objects may be different, this network is always the same. So the pattern of interaction between objects is intrinsic to the DCI paradigm. And that's what a context is. A context tells how the roles interact with each other in order to achieve some mental model. So even though specific interactions can be in any order and they're emergent and they're complex, the form of the interactions is designed. So if you were to draw an object diagram, instead of a class diagram, this is what you would draw. And these are kind of the main highways of interaction between the objects that are participating in some scenario. And that is a natural fit to what the end user is thinking about. And the whole name of the game here, the whole name of the game in object-oriented computing was to get the stuff in the computer reflect the stuff that's in the end user's mind. Now, coming back to the point you made earlier, this form lives within no single object or class, so we need to give a home for it. So objects are too small, so what we do instead is we create a new concept called a context. So if this is about making a reservation for some trip, there's some series of interactions between the objects. Between the flight that I'm booking, between myself, my family, a travel agent, the seats, the cities. those are the roles. So I have a role like journey end, another role like journey start, maybe another one for the route map. And these roles interact with each other, and I can just read that in the text of these role methods. These role methods interact only with each other. So this is the whole scope of the program. A role method is not allowed to access any other object. It may only access an object by its role name, and the role must be in the same context. So what I've done is I've localized the use case logic, the business logic for this operational model, and made it, in theory, a lot easier to reason about. Now, it's not just in theory that these things are easier to reason about. As I said, my hidden agenda here is to get you guys involved. Anyone in school working on a master's or a PhD? This guy just did his master's thesis, Hector Adrian Valencantos, at Rensselaer Polytechnic Institute in New York. And he wrote several programs, about 4 of them, in both Java and in Trygve. And then they instrumented the study for how programmers would understand these, find and fix bugs in them, extend the functionality. And so here's the Java program that has a menu structure, a menu item, menu interface, the main program, and a menu component. And the size of the circles represents the amount of time that the programmer spent in each of those files or in each of those classes. Here's the DCI program, which has an analogous thing for menu structure, for menu component, for menu item. This is a very small main. People spend like 90% of their time in one place, which is the context, called the menu interface. Now this means less context switching. This means less going between windows. This means that everything is in the same place. So instead of having to deal, another one of these myths is coupling and cohesion. What a bunch of crap. I mean, first time I really spent some time with Larry Constantine, he described to me where coupling and cohesion come from. And he said it's so broadly misunderstood. So is cohesion a good thing? Yeah, cohesion's a good thing. Is coupling a bad thing? Let's say you can make the coupling in your system go to 0. Well, then it wouldn't be a system, would it? It'd just be a bunch of disembodied objects. No, there's nothing wrong with coupling between objects. Absolutely nothing. And if the essential coupling between your objects is less than the essential coupling between the real entities in your domain, be afraid. Be very afraid. Because evolution will get you. And when that change comes along, you're going to have to increase the coupling. And it's really painful. And this is why I say, classes, there's nothing wrong with a class having a fat interface. Gives me this. It allows users to focus on one thing, which is an expression of their mental model of how these things work. So we finally actually have some empirical research results. These are published. At least as his master's thesis, and I think they're on the way into a journal. A lot of you are kind of nerds, and you'll usually get the question, yeah, but isn't this just multiple dispatch? Well, but that's using one algorithm based on multiple types rather than a sequencing of multiple algorithms based on multiple types. So it's kind of in the same area, but it's a little bit different. Aspects. How many of you use aspects? Okay, nobody. Good. Oh, one. Oh. I like to tell, the reason you really come to these things is to get the little stories. So I was program chair of UPSA in 96. And I went to the conference in 95 because I wanted to kind of scope out the politics. And there was a guy there who had submitted a paper. His name was Gregor Kixalis. And the program committee had rejected the paper. And it was about what today we recognize as aspect-oriented programming. The program chair overruled the program committee and invited Gregor to give a keynote based on this. And of course, there was a lot of hard feelings and grumbling. So I wanted to talk with Gregor to kind of scope out the politics. I said, so Gregor, what's this all about? He said, well, he says, I'm the meta-object protocol guy. I wrote this book called The Art of the Object Protocol. And I'm a Lisp guy. I mean, true programmers work in Lisp because you need reflection and you need that kind of ability to be able to do any reasonable programming, to make it flexible. Otherwise, and the Java people just don't get it. And they can't get it because you can't do this in Java. It's impossible. So I have no way to talk with them. And they keep asking, well, I can do something equivalent in Java. So I have created a system that shows just how awful this would be in Java if they were to implement it. And I've called it Aspect J. That's where aspects came from. At the AOSD Aspect-Oriented Conference 2 years ago in near Berlin, I asked the audience, does anyone here believe that aspects work? I was giving the keynote and 5 hands went up. And then Christina Lopes, who was the co-inventor of aspects, gave the end note, and she said that aspects were based on 4 assumptions, that 4 things were true 17 years ago. And in 17 years, not one of those 4 things has borne out to be true. They killed the conference the next year. So, I mean, there have been a lot of people trying to solve this problem. I wrote this little paper. If you want a copy, I can send it to you. It's called The 6 Wise Men and the Elephant. And so there's been these 6 wise men around the elephant with aspects and dependency injection and multi-paradigm design and a lot of other crazy ideas that kind of are in the right neighborhood, but they really don't solve the problem. Maybe just 2 more sets of slides here, and then we can start working into questions. I forgot to show this one in Copenhagen. Nerds always want to see the family tree of programming languages, and of course all these family trees are wrong, like all family trees. But this is the best I could put together. So in the beginning there was Algol 68, and Simula kind of came from that, and I mean C++, is a direct descendant of Simula. Björn Strostrup did his PhD thesis was doing simulation of architecture, and running the simulations in Simula would have expended the entire department's computer science budget. So there was this PDP-11 in the corner with a C compiler, so he wrote a preprocessor for it to make it look like Simula, and got free computing, could do a lot of simulations. And then C# kind of comes from C++, and D. What should D have been named? D is the wrong name. P, right? Or L. This should have been P. Right? So in the beginning there was what? What was before C? And before B? No? BCPL. So it's BCPL, then B, then C. What comes next? P, and then L. So what was named, what was named C++? Ending time. How was it named C++? This is why you really come to these seminars, is to hear these stories. No? Good guess. No? So when Strostrup came to Bell Labs, he got put in Brian Kernighan's department, and he called it C84. He was aspiring to trump the C standard and create a new C. So he called it C84, as in Fortran 77 or Algol 68. And the C community at that time said, nah, you're just the new snot-nosed kid, wet behind the ears kid from the UK. You don't know anything about the C standard. We have our own ANSI committee for C, X3J11, and you don't know anything about this. And then, of course, X3J16 was formed for the C++ standard, and X3J11 went and made what we now know as ANSI C. Well, 2 things are funny. One is, if you program an ANSI C, almost all of its features came from, well, what was the language called back then? It was called C with classes. That's what Strostrup called it. back in the early 80s when it came to Bell Labs. But they wanted a better name for it. He called it C84. He couldn't call it C84. C84, 1984. What do we know about 1984? Huh?
Something with Terminator.
Right genre, wrong actor. 1984. George Orwell wrote a book called George Orwell. And in fact, it was a book largely about language. He's a brilliant linguist. So it's this interesting Russian-English dialect they speak in there. And the language was called, do you remember? Newspeak. And Newspeak was a government standardized, mandated language, and you could get a fine for using certain words in the language like very, because very tended to get you, it's a superlative, and that makes you emotional. And we're going to be a purely rational society and based on rational discourse and get rid of emotion. So you could not say something was very good. You would say that it was close. Double plus good. C double plus. C 84. He got his revenge. That's where the name comes from. That's why you really come to these. But I mean, if we look at these languages here, these are all class-oriented programming languages. You think in classes, you write class diagrams. What you write in the code is classes. And so the program is a model, but it's only a model of the classes of the system. The classes are not the objects. They're the scaffolding we use to build the objects. So it's not even a blueprint. It's a diagram of the scaffolding. And then there are languages that we arguably can call object-oriented programming languages. You know, very, very early Smalltalk didn't have classes. I think the first Smalltalk, they just had kind of a contest among themselves to see if they could write an entire system in one page of code. And they ended up with Smalltalk 72. And then it evolved into Self, which is Dave Unger's language and someone else whose name I can never remember, and eventually into JavaScript, which also, of course, inherits something from C, which is outside of all of this. Trygve takes its syntax from Java because worse is better. It borrows a lot of the ideas from the DCI implementation in Squeak, like garbage collection and being a single hierarchy language rather than a dual hierarchy language. That is, classes are represented by objects. There's not a thing called a class and a thing called an object. They're the same thing. The whole notion of object thinking, it borrows from Smalltalk 72 and JavaScript. But the syntax is basically Java, and with a very, very few additions. And in spite of the fact that there's very few additions, I get this really, really nice property, which is if I look at a Java program as a model, all that the code talks about, all I can reason about from the code is the class structure, which is if you're into DDD, this is the domain structure. But there's nothing about the use cases. Now, how many of you sell classes? No, I mean the revenue and the business focus is on the use case. That's what we sell. We sell use cases. We sell functionality. We don't sell classes. But yet our code, if you're programming in Java, does not allow us to reason about the number one thing that we sell. And we cannot find it in our code. If you have some feature you're selling to your customer and I say, can you go please draw a circle around this in your code? You can't. So how in the hell can you know it works? It's like Stevie Wonder said, we believe in things we don't understand, we may suffer. But we believe because the green bar comes up. And that's very dangerous. And I mean, I've watched the quality of software plummet in the past 40 years. It's really been disheartening. And I think this is a big part of it. So in Trygve, I still have my classes, just like we do in Java. But I also have roles which are names for the objects. And so I can start to talk about the objects, and I have contexts, which are a document, a model of the structure of the use cases. And they're all in the code, and they're all readable. So in one piece of code, I'm able to represent all of these models, and unlike UML, it compiles and runs. So in some sense, I'm not doing anything new here. All of this stuff exists in UML. It's just that most people don't know much about interaction diagrams and the semantics of interaction diagrams, which Trygve pushed very hard to get into UML, which Brand Sellis tried to get people to understand, just he gave up on getting people to understand it. So in the code itself, I can conceptualize about objects and the roles they play, as well as the use cases that enact them. So I can start to understand my code. If I can understand it, it's more likely that it's right. It's more likely I'm going to be able to evolve it. It's more likely I'm going to be able to find where to evolve it. And it looks like the research efforts bear this out. Now this talk has been about Trygve. You can use a style of programming in C++ that allows you to do DCI. It's very close in Ruby. Ruby is almost there because you can represent a role by a module, and then you can inject a module into an object. The problem with Ruby is Ruby has sticky injection. And I've talked with Maz to try to convince him that we should have a way more cleanly to uninject, and that's going very slow. And I'm probably not going to be traveling to Japan for another year or so. So be a while before I see Maz again. You can do it in Smalltalk by modifying a method table. There are also implementations at Python, which I stay away from. And actually, there is a JavaScript library. So JavaScript isn't totally there. You actually need some kind of, I think, syntactic support. I don't know enough JavaScript to talk intelligently about it. But if you look at most modern or popular programming languages, someone has done some kind of implementation of DCI in that language. The reason we're doing Trygve is that, like in Ruby, Ruby is almost right. I can't uninject a role. So it's almost right. And we keep asking the question, what would it look right if we were to do it right? And that's what Trygve is. So we're trying to just, throw away anything that gets in our way in terms of legacy class-oriented semantics so that we have the freedom to do what we want to do in real object-oriented programming.